Okay, hello student, good morning. Am I audible? Good morning to all. Yes, how are you all? कैसा है सब बढ़िया? Fine. Okay, so yesterday I discussed the third method of the roots of equations concept, Newton-Raphson method. Okay, and I discussed the 2 or 3 example in the last lecture. Okay, so this is procedure to derive the formula of roots of equation. The formula of Newton-Raphson method by using a Taylor series. And the formula is xn plus 1 is equal to xn minus f of xn upon f dash of xn, and thus use n is equal to 0, 1, 2, 3, 4, and so on. You will get the iteration. Okay, and this is a procedure to evaluate the f of x0 if it is not given. Just check one interval a b where f of a negative, f of b positive, and after consider its average value as a x0 if it is not given in the example. Okay, but in some questions that is the value of x0 is already mentioned in the question. Okay, so that first example that we had discussed in the last lecture, x cube minus 5x plus 3, and this is the 2 iteration is required for the answer. So x1 and the x2. Okay, it's also consider the derivative of the function x cube minus 5x plus 3, and its derivative will be 3x square minus 5. Okay, so in denominator we'll consider this answer f of x upon f dash of x. Okay, and then after we'll simplify that and we can find the required answer. Okay, so first we'll get x1 by using the value of x0. Okay, and then after for x2 we'll use the value of x1 to derive the answer, and so on. And that is the second example, which involves one trigonometric term 3x is equal to cos x plus 1, and that is its derivative 3 plus sin x, and here x0 is not given. So first we'll check the value of x0 by finding some interval, one interval AB where f of A is a negative and f of B is a positive. Okay, and then after consider it average value, here 0 at a 0 functions get negative value -2, and at 1 functions get a positive value, it is 1.4597 something. And then after consider it average value, that is a 0.5, 0 plus 1 by 2, that will be the 0.5, and now use this value as a x0. Okay, your first approximate iteration, and then after check f of x0 and f dash of x0, and then use this in the formula x1 is equal to x0 minus f of x0 upon f dash of x0. Okay, and just simplify that all this value you have x0, f of x0, and f dash of x0, just put it here in the formula and simplify that. Okay, so we get first iterations 0.6083, and now use this is the x1 0.6083, then after check f of x0, replace 6083 in the 3 into x minus cos x minus 1 and check it value, and then after replace this value in the f dash of x0 and check x2, that is x1 minus f of x1 upon f dash of x1. Okay, and simplify that, we'll get answer 0.6071. Okay, we required answer correct up to 4 decimal place, so consider the 4 value after the decimal. Okay, in your answer, and you can also fix this value in your calculator, so it will be display the 4 output. Okay, 4 numbers after the decimal, and then after find the x3, use the x2 0.6071, then after its function output, derivative output, and then use the formula x3 is equal to x2 minus f of x2 upon f dash of x2. Okay, so replace this value in this formula, the data, and check it output, we get answer again 0.6071. Okay, so x2 we get 0.6071, and x3 is also 0.6071, so they both answer are matched up to the 4 decimal value. Okay, means after the decimal 4 value are matched. So we'll stop our process here and we'll consider this is our final answer for the given equation. Okay, and that is just approximate value. It is not an exact answer for this equation. And then after we had discussed the third example for x into sin x plus cos x, where x0 is given that pi. Okay, and check the answer correct up to 4 significant digit, means correct up to 4 decimal places. Okay, so first consider fx, then it is derivative that we already discussed in the last lecture. Okay, how we can derive this derivative f dash x, that remaining term will be x into cos x. Okay, and here x0 is equal to pi. You have to check the roots near to x is equal to pi, means x0 is equal to pi. That is our approximate root. And now start the procedure with that x0 is equal to pi. Okay, then function output that will be -1, derivative output that will be minus pi, and check the x1. Okay, that will be x0 minus f of x0 upon f dash of x0, and then use the x1 as a 2.82328. Check the function output, derivative output, and check the x2. Okay, and that will be x1 minus f of x1 upon f dash of x2. Then use the x2 as a to derive the third iteration. Check the function output, derivative output, and use to derive the x3. Okay, so you'll get 2.79839, and then use to the x4. Check the function output, derivative output, and you'll get answer 2.79839 something. Okay, so this correct up to 4 decimal value. Okay, at x3 we have 2.7983, and in x4 we have 2.7983. Okay, so both answer are matched up to the 4 decimal. Okay, 4 decimal तक को correct है. ठीक है, so we'll consider this our required answer. Okay, because in the question it is mentioned that you have to check answer correct up to 4 significant digit, means 4 decimal place. If it is given that 5 significant digit, then we'll derive the more iterations. Okay, to match the answer correct up to 5 decimal place. Clear? If it is mentioned here 6 significant digit, then we'll derive the more iterations. Okay, x4, x5, x6, and so on to match answer correct up to 5 significant digit. Okay, so if it is mentioned here 5 digit, okay, 5 significant digit, we'll consider in answer a 5 number. Okay, after the decimal, because then after we can match that. Clear? If we consider only 2.79 here, so we cannot match it is correct up to 5 decimal, 6 decimal, and so on. Okay, so how many decimal is required in the questions? Okay, in the answer, that you have to mention in the number of iteration. Okay, that value should mention in this number of iteration. Clear? So this third example we had completed in the last lecture, and now this is the fourth one. Find the positive root of the equations x equal to cos x by using the Newton-Raphson method, correct up to 3 significant digits. Okay, I think this example we had already completed in the bisection method. Okay, in this the data is there. X is equal to cos x. That function was same. Let us check it. And now we'll solve this example by using the Newton-Raphson method also. Okay, so based on that we can get ideas which method is more effective. Okay, means which method will get a fast answer. So here this questions. Okay, x is equal to cos x, and that example we had already completed in the bisection method, correct up to 2 decimal place. And to solve the answer correct to 2 significant digit, that's required the 11 iteration. Okay, here at 11 iterations we get our answer. Okay, so in the bisection method, okay, function is same, that x is equal to cos x. Okay, it means x minus cos x equal to 0. Clear? That is same functions we have. And now we already completed this example in bisection method, means we already derived its root in the bisection method. Okay, and we get answer up to the 11 iterations, means to get the answer we required the 11 iterations here. Okay, and now we'll solve the same example. Okay, same question, same equations to solve by using Newton-Raphson method. Okay, and by using that we can check that which method is more effective. Okay, which method is will get a fast answer. Okay, means how many iteration is required in the Newton-Raphson method. Okay, let's check that, and based on that we'll get idea which method has a more rate of convergence. Okay, let us check it. X is equal to cos x, that is the equations we have, and let us solve it by using the Newton-Raphson method. and let us check that how many iterations is required to get the required answer. Okay, so x is equal to cos x by using NR method, correct up to 3 significant digits. Okay, so fx is equal to x minus cos x. X is equal to cos x means just consider as f of x is equal to 0 form, so it will be x minus cos x. Okay, and now its derivative, so derivative of x will be 1. Okay, x minus cos x, this is a function, and derivative of x will be 1 minus as it is, and derivative of cos, okay, that will be the minus sign, so it is a minus sin x, and now simplify that, it will be 1 plus sin x. Okay, so derivative of the x minus cos x will be 1 plus the sin x. Clear? And now here x0 is not mentioned, okay, in this data x0 is not given, so let us check the x0 by using the uh, interval a b, where f of a is a negative, f of b is a positive. Okay, so at a 0, what is the output of f of 0? That is 0 minus cos 0 form. Okay, replace a 0 in the function, so it's form of 0 minus cos 0, and 0 minus cos 0 means minus 1. Okay, cos 0 output is the 1 and negative sign there, so it will be the minus. Okay, so f of 0 is a negative. Clear? And now check f of 1. Okay, in this radian mode, function is there x minus cos x, and just use the x is equal to 1 in the function, so it will be the 1 minus cos 1. 1 minus cos 1. Okay, just consider radian mode first and then check the function, so it will be 0.459697694. Okay, and just round off up to the 4 decimal, so it will be the 0.4596. Otherwise you can also consider a 97 value. Okay, that is both are correct. So this is a 0.4597, that is the positive value. Okay, so we can consider our roots lies in between 0 and 1, and now we consider x0, so use it average value a plus b by 2, and that is 0 plus 1 by 2, and that is the 0.5. Okay, so we have x0 is equal to 0.5. Okay, so start with this value to find the x1. Okay, and now check f of x1 means f of x0. So f of x0 means you find the answer of x minus cos x at 0.5. Okay, so check it in your calculator and reply in the chat box. Now try to solve it by yourself. Okay, first. Yes, how many of you have calculator right now? કેટલા પાસે કેલ્ક્યુલેટર છે અને કોની પાસે નથી હજી સુધી? Okay, I will ask anyone to the answer. Okay, you should have the calculator, because without that you can also verify that we cannot solve any questions. Okay, any step. Good. Okay, so check the answer of the function value at 0.5. 0.5 minus cos 0.5. Just reply that 58. Okay, minus 0.37758. Good. That is the answer of function output at a 0.5. Okay, so here mentioned 0.377. Okay, 5, 8, other 5, 7, 6. You can also consider. You just consider 5, 8 also here. Okay, otherwise consider 7, 6. That is also one correct form. Okay, approximate value. And now the derivative output 1 plus sin x. So 1 plus sine of 0.5. Okay, you will get 1.4794. Okay, 1.4794. That is the value. Okay, and now write a formula of x1. Otherwise, directly replace the data as per the formations of the formula and check the answer directly. Okay, so x1 will be x0 minus f of x0 upon f dash of x0. Okay, and there is one negative sign here, and here also one negative signs will be arise there. Okay, so negative negative will be positive. Okay, so just consider 0.5, and after plus write a bracket, and in bracket mention the values of f of x0 divide 0 1.454794. That will be 0.7552. Good. So you'll get first iteration 0.7552. Yes, how many of you get this answer? Good, sir, good. Now try to find the second iteration. For any problem, any doubt, please ask me. Okay. For any query, any problem that you have to face right now, please ask me. Without that, cannot get the answer. Okay, so x1 is 0.7552, and you can just replace 0.5 here. And now that is negative sign here in between the first value and the second value. And here it is also function output is also negative. Okay, so just you can consider directly positive here. And in the bracket write 0.37758 divide 1.4794. Okay, and just press enter, you will get answer 0.7552. So use x1 is equal to 0.7552. Now check function output. F of x1. Yes, that is 0.027065 something you will get answer. Okay, so you can consider 0.0271. Either you can also consider 0.65. Okay, that is also one correct form. You can also consider up to the 3 digit, up to 4 digit, that will be the 0.271. Either you can also consider 0.65. Okay, so let's consider 0.271, and now check it function output 1 plus sin x. So 1 plus sine of 0.7552. Okay, that is a 1.6854. Good. 1.6854. Okay, and now check x2. Okay, there is no any negative sign to any value. Okay, so here just consider 0.7552, then after minus. Okay, and then write 0.0271 divide by 1.6854. Okay, you can directly type this form in your calculator. Okay, and you will get this direct answer without finding first division and then after subtracting. Okay, just type in your calci 0.7552. Okay, then after write minus bracket, and then write this division form 0.0271 divide by 1.6854. 0.054. Bracket over and then press enter. You will get the answer 0.7391. Correct? 0.7391. You will get this answer. Okay. And here, what is the requirement in the answer? You have to check correct up to 3 significant digits. Okay. So now observe the x1 and x2. So in x1 we have 755 and in x2 we have 739. Okay. So they are not matched. Correct up to 3 decimal place. So again repeat this procedure. Use the x2 and derive the x3 0.7391. Now check function output. Yes, that is the 0.4 times 0.248. Okay. In your Kelsey, okay, without using the fix button, if you try to solve this answer, you will get this form. Okay. That is the 0.7391 minus cos 0.7391. Okay. You will get this form without fixing value 2.488 of 13, okay, into 10 raised to minus 5. 10 raised to minus 5. You know how we can convert the normal form, okay, in this decimal form, then it is very easy there. But if you get confusions in this form, okay, what is meaning of 10 raised to 5 and what does it mean? So how we can remove this 10 raised to 5 in calculator? Okay, so you just fix your answer in Kelsey. Okay, how we can consider the fixed answer? Okay, just press the mode button. Okay, 3 times. Press the mode button, and there is a 3 option display: fix, SCI, and norm. Okay, fix, SCI, and norm, and then after press 1 to fix. Now in display there is 0 to 9 option is given there. Okay, so consider a 9. Then in display the 9 digit will be display in your Kelsey. Okay, after the decimal 9 digit will be display in your Kelsey. So just press 9, and now you can check this answer. It will be 0.00024881. Is it getting or not? In place of this answer, you will get this form 0.00002488. Okay, again I repeat this. In the normal form, okay, in your Kelsey you will get this answer 10 raised to minus 5 something. It is also correct answer there. You will get a right answer at last if you are using that. But we need this form, okay, to simplify directly, because 10 raised to minus form, sometimes we forgot about this value and we get a wrong value at last. Okay, so how we can get this normal form? So just press mode button 3 times. Okay, mode button 3 times. First it will be COMP, SD, and regression, then after degree, radian, gradient, and again press that. You will get a 3 option: fix, SCI, and norm. Okay, now we need to fix that. So press 1, and now in display there is 0 to 9 options will be given. Okay, 0 to 9 means how many digits you needs, okay, to for your answer. So if you need a 5-digit, 6-digit, 7-digit, then you just press as per the value. Okay, we need a 9-digit after the decimal. Okay, just press 9 and you will get your answer in this form, 0.0002488. Is it clear to all? Is there any doubt in this case? Because this is also important for us. You should know all this command and options in calculator. Okay, so here write the value 0.000024888. Okay, 4 times 0, then after 2488, and then after check the function output, derivative output, that will be 1 plus sine x. So 1 plus sine of 0.2488, bracket over, and you will get this is 1.0000. Okay, you can consider this is a 1. Oh, sorry. Let's me check it again. 1 plus sine x. 1 plus sine of 0.7391. Yes, is the form. That is not year 1. Okay, just remove 1 plus sine 0.7391. Yes, that is 1.67. 6736. Yes, that is the right answer. 1.6736. Now check x2, x3. That's very good. X3 is 0.7390. Good. So let us check it. X3 0.7391 minus, and then after write all this value in the bracket, 0.002488 divide 1.6736, bracket over, and you will get 0.7390. 0.7390. Clear? So we need answer correct up to 3 significant digits. So check x2 and x3. So in x2 we have 739. Okay, in x2 we have a 739. Okay, that is a 739. That is 3 digit after the decimal. And in x3 we have also 0.739. That is a 3 digit after the decimal. They are matched. Okay, so that is our required answer, 0.739. Okay, because this is repeated up to the 3 significant digit, 3 decimal places. Okay, so our required answer is 0.739. Okay, for this example. Okay, so now check this. How many iteration is required here? First iteration, then after second one, and third one. Only 3 iteration is required to get the answer. Okay, but if we apply the bisection method to the same equations, okay, there is 11 iteration is required. Okay, that you already checked in this example of bisection method. Okay, that is required 11 iterations to get answer correct up to 2 digits, 0.73. But here it is 3 digit. Okay, one more digit that you have to also match. So that required only 3 digit here. Only 3 iteration is required here. Okay, so what does it mean? Okay, the Newton-Raphson method, okay, comparison to the bisection and comparison to the regular falsity, the Newton-Raphson method is more effective to get a fast answer, okay, to get a fast result that is required in the question. Okay, so rate of the convergence means which method is more effective to get a fast result. Okay, to get a more accurate answer. So the Newton-Raphson method is more effective. Rate of the convergence of this method is very high. Okay, comparison to the bisection and Regula-Folsi method. Okay, if the four same functions and we have to solve the roots of this equation. So for same functions, I consider here x is equal to cos x. Okay, in the bisection method, it's required the 11 iterations to get your answer. Okay, 11 iterations to get your answer. In Regula-Folsi method, if we solve this example by a Regula-Folsi method, so I think it's required 8 to 9 iterations. Okay, to derive the same answer. Okay, 0.739 and so on. But in Newton-Raphson method, it just required the 3 iterations, okay, to derive the required answer. Okay, means up to the 3 significant digit, it's take only 3 iterations to get the answer. Okay, so comparison to this one, okay, now we have only 3 method to find the roots of the equation. So compare this all one. Okay, so when you compare this Newton-Raphson method, the third method is more effective method to find the suitable and very quick answer. Okay, just it's required 3 to 4 iterations, okay, to derive the answer for a same function. Clear? So rate of the convergence, you can apply any method in real life. Okay, you can also apply bisection method, you can also apply Regula-Folsi method, you can also apply Newton-Raphson method to derive the answer, but this method is a more suitable method. Okay, more effective method to derive the answer. Clear? So this is a case. Okay, you just consider any functions. Okay, any function here we consider cos x because that you already completed one uh, uh, solutions of these equations in bisection method. Okay, and that's required 11 iterations that we already checked. Clear? And if you solve these questions by using a Regula-Folsi method, I think that's required 8 to 9 iterations to predict the answer 0.73 something. Okay, but in the Newton-Raphson method that we already checked in this case, it's required only 3 iterations. Okay, just take the 3 iterations and you will get your answer. Clear? So it's the more effective method. So is it clear to all this all the 3 methods? Is there any doubt in any case? Okay, this totally depends on the formula. If you know the formula and how we can implement to derive the roots, okay, if you know the procedure, then you can solve any example. Okay, any types of equations, if it is asked in the exam, you can easily solve that. Okay, if you know the procedure, know the formula, and how we can implement to derive the next iterations, if you know this, okay, then you can solve any example. Okay, in this PPT is involved 3 to 4 questions related to this particular method, but there is some 5 to 6 example is are given in the assignment, so try to solve it by yourself also. Okay, and check it answer. But in real life, okay, these 3 options we have to find the roots. 3 options we have to find the roots. So this method, the third one, Newton-Raphson method, is more suitable, more effective method to derive the answer. Clear? Because it takes the less iterations. Okay, comparison to the bisection method and Regula-Folsi method. Clear? So this is a case. And now next one is there. We can also use this Newton-Raphson method to find the square root value. For example, we can easily solve it by calculator that. Okay, for example, we need a square root of 25, then you can easily say it is a 5 that. Okay, square root of 36, it is easily we can say 6 that. Okay, 29, then after 36, 40, anyone. Okay, any value we can directly check from the calc that, but we have its another form, another way to derive the square root answer. Okay, any n, okay, any perfect number that consider here, any number you can consider here, and we need it a value. So in calc we can directly predict that. Okay, some fixed standard value we have that you already know its square root answer. Okay, but which is the alternative way to derive its answer, to derive its approximate value. Okay, so by using Newton-Raphson method, we can predict its answer also. Clear? So we need to find the square root n by using a Newton-Raphson method. Clear? Square root of n value by using Newton-Raphson formula. So let us first derive formula, and then after we'll use this formula to predict the answer. For example, we need answer square root of 59 here without the calculator. So how we can predict this answer? Okay, we need answer square root of 101. So how we can check this answer? So we'll use this formula to derive the uh, iterations, okay, of your required answer. So how we can derive this formula? That is, a procedure is mentioned here. Okay, first consider a function. Okay, now we need to create one functions that. So x is equal to root n. Okay, this is a form is given, x is equal to root n. Let's consider x is equal to root n, and now remove the square. Means remove the square root from the n. Okay, so how we can remove this root? So for that we will apply the square both side. Okay, that will be the root n with the power 2. Okay, and square with the power 2, that will be removed. Okay, square will be removed. Okay, so what is remaining? That is n. So x square is equal to n. Clear? And now let us consider this is a function. So fx will be x square minus n is equal to 0. Okay, n means any number. Any number you can consider here. So fx is equal to x square minus n is equal to 0. And now we need its derivative. So f dash x will be the 2x. Okay, derivative of x square, that is a 2x, and n is a constant value. So derivative of n will be 0. Okay, so remaining term will be 2x only. So f dash x is equal to 2x. And now by Newton-Raphson method, we have its formula is equal to xn plus 1, that is equal to xn minus f of xn upon f dash of xn. Okay, f of xn upon f dash of xn. And now replace the function output here. So xn as it is here. And what is f of xn? We have f of x is equal to the x square minus n. Okay, this form we have. So now we need xn. So xn will be xn square minus n. Okay, just replace x to the xn in this form. So xn square minus n, and here f dash of xn. So that will be f dash of x, we have 2x. So f dash of xn will be 2xn. Clear? So replace here 2xn, and now simplify this. Clear? So what is the simplification form? We consider LCM 2xn. So here it is a 2xn, clear, in the denominator, and 2xn will be multiplied with this xn. So it will be the 2xn square minus xn square, and it is minus minus will be a plus. So it is a plus n. Okay, and 2xn square minus xn square. So it will be xn square only. 2 minus 1 will be 1, and it is a plus n divided by a 2 xn. Clear? So this is a formula to derive the iteration answer of n square root form. Okay, n square root of n. Clear? Xn plus 1 is equal to xn square plus n divided by 2xn. Clear? For example, we need to find 59. So this is n is a 59. Okay, and then choose suitable x0, and then apply it here in this formula. Find the x1, x2, x3, x4, and so on. You will get the answer of square root of n. Clear? Square root of 59. So this is the procedure to derive the formula of a square root n. Clear? Now let us implement to one example. So use the iterative formula of root n to find the values of square root of 28, then after 65, and then after root 3. Okay, that we can easily solve in the calculator, okay, within the 1 second. But let us check that how we can check the answer of root 28 by using the Newton-Raphson method. Okay, so we have the formula of root n, that is equal to xn plus 1 is equal to xn square plus n divided by 2xn. Okay, and now we need x0. Okay, that is evaluations pattern, that fx you can consider x square minus 28, then after f dash x will be 2x, but there is not required in this equation that we need xn square plus n is equal to 28 here divided by 2xn. Okay, and for first iterations use the n is equal to 0, so it will get x1 is equal to x0 square plus n divided by 2x0. Okay, this is our first iterations formula. So we need x0. So how we can choose x0? Okay, so answer of 28 will be in between 25 and a 36. Why we consider 25 and 36 here? Because this is a perfect square root. Okay, perfect square root means its answer is will get a perfect value here 5. Okay, and here answer will get a 6. Okay, these are the perfect square root. Therefore, we are using this 2 value here. We can also consider 26 that, but it's take a decimal answer there. So just consider the boundary of 28. Okay, okay, from which value, which two values we have, which two perfect square root we have, which answer of 28 will lies. Okay, so answer of 28 will be in between 25, square root of 25 and 28. Clear? The answer of 28. Okay, whatever answer of 28 that we don't know right now, but this answer of 28 will be in between square root of 25 and a square root of 36. Okay, so based on that we can predict a x0. Clear? We can consider a one starting value to predict the answer of x1. Clear? To predict the answer of first iteration. So, and you can also check this one output also 5 and 6. Okay, why consider f of 5? Because we get negative answer, and f of 6 will get positive answer. So root of 28 will be lies in between 5 and 6. Then you can also use this method. Okay, okay, what is the answer of 28? Okay, an answer of square root of 28 will be lies in between square root of 25 and square root of 28, square root of 36. Okay, means your answer of 28 will be lies in between 5 and 6. Okay, answer of 28 will be lies in between 5 and 6. So any value you can consider as x0, either 5 or either 6. Clear? You can start with any value. You can consider x0 is equal to 5, either x0 is equal to 6. Okay, you will get the same answer at last. If you start your procedure with by taking x0 is equal to 6, you will get the same answer at last. Okay, and you can also consider 5 as a x0, and you will get the same answer at last. But your answer of the 28, okay, square root of 28 will be in between 5 and 6. Clear? So here f of 5 is less than 0 and f of 6 is greater than 0. Then roots lies in between 5 and 6. Clear? This is also one procedure there. But how we can predict a 5 and 6 here? So we'll get idea based on this inequality. Okay, root 28 will be lies in between root 25 and root 36. Okay, why 25 and 36? Because its answer has a perfect square root. Okay, perfect answer, perfect root there. So let us take x0 is equal to 5. Okay, you can also consider x0 is equal to 6. That's also will get the same answer. Okay, at last. So x0 is equal to 6, and this is the table for the evaluation. Number of iterations. Then after write a value of xn, and then write a formula. Okay. So first iterations start x0 is equal to 5, and now formula of x1 that will be x0 square plus n divided by 2x0. Clear? X0 square plus n divided by 2x0, and x0 we have 5. So 5 square plus n is a 28 divided by 2 into 5. Clear? So just check this value. 5 square is a 25 plus 28. Okay, n means a 28, not a square root of 28. Okay, n is a 28, so 5 square is a 25 plus 28 divided by a 10. Okay, so you will get answer is a 5.3. Clear? 5.3. This is answer of this one. That is a 53 divided by 10, and that will be the 5.3. This is the first iteration. Okay, first approximation answer of root 28. And now let us check the second one. Second iterations will be x1 is equal to 5.3. Okay, now formula of x2 that will be x1 square plus n divided by 2x1. Clear? Just consider n is equal to 1 in this formula. So we'll get x2 is equal to x1 square plus n divided by a 2x1. And now use 5.3 as a x1. So 5.3 square plus n is a 28 divided by 2 into x1 means a 2 of 5.3. Okay, so we'll get 5.2915. Okay, 5.2915. 5.2914. 5.3 square plus 28 will be 56.09. Okay, the numerator will be 56.09, and denominator will be 5.3 into 2. 5.3 into 2, that will be 10.6. Okay, so here it is 10.6, and find the division. So we'll get 5.2915. 5.2915. Okay, that is the second iterations x2. Clear? And now let us check the third iterations x3. x2 is equal to 5.2915, and now formula of x3, that will be x2 plus x2 square plus n divided by 2x2. Clear? So just replace all this value. X2, that is a 5.2915 square plus 28 divided by 2 into 5.2915. Okay, and check this output. You will get the same answer, okay, as the x3, that is a 5.2915. Okay, 5.2915 all square. Then after add a 28 and then divide 2 into 5.2915. 915. Okay, and check this output. You will get 5.2915. Okay, the repeated form 5.2915. And we'll stop our procedure here. Why it is? Because x2 is also the same answer 5.2915, x3 is also the same answer 5.2915, and when we find x4, okay, based on the x3, we'll also get the same value 5.2915. Okay, so this will now repeat it. Clear? This will be repeated in the x2, x3, x4, x5, and so on. So we'll stop the procedure at whenever we get two nearest iterations same. Okay, so just stop your procedure and consider the answer of root 28 is equal to 5.2915. And you can also verify this value in Kelsey. Just find the root 28 only. Okay, and you will get this answer 5.2915. Clear? So that's our correct answer by using the iterative formula. Okay, this is called iterative formula to predict the answer of root 28. Clear? That is easy, that just we need to predict the right x0. Okay, and you can also check the x0, that what is answer of root 28. Okay, so root 28 will be in between root 25 and root 36. Okay, because this has the perfect square root, we can use the perfect number as a x0. Okay, and if we start x0 is equal to 6, you can also get the same answer at last. Okay, so is it all this example and the procedure to evaluate the square root n? Have you any query, any doubt? So ask me. Okay, good. Now for practice, you just write root 65, okay, by yourself, and we'll check the answer in the next lecture. Okay, try the root 65. Clear? By iterative formula.